Okay, a geometric sequence. That's our first two blanks. A geometric sequence how is it different so far from what we just did? Instead of arithmetic. So this is geometric instead of what we just learned, which was arithmetic. Is a series of numbers where there is a common ratio. Between consecutive terms. That means you always multiply or divide the same value to reach the next term. The graph of a geometric sequence is exponential. If you're not sure what that means, exponential is a little bit curved, so the graph is going to like curve upward instead of being a straight line like it would be if it was linear, like it is for an arithmetic. All right, let's look at these problems and find the common ratio. So you can just do these by thinking, what do I multiply 8 by to get 40? Or you can actually create ratios, which are like fractions, right? So to create a common ratio, we would go 40, which is our second term, divide 8, which is our first term, and 40 divided by 8 is 5. Well, let's see if we get the same thing if we do 200 divided by 40. So 200 is the third term. Divide it by 40. Use a calculator if you need to, but just you can cancel out a couple of zeros. And then 20 divided by 4 is simply 5. Again, right? Let's check the other one. So what if we take 1,000 and we divide that by 200? Again, we can get rid of a couple of zeros. What's 10 divided by 2? 5. So every time we did this division or did these ratios, we got the same answer of 5. That tells us our common ratio is 5. Now, we could continue our pattern by multiplying by 5. So 8 times 5 is 40, 40 times 5 is 200, 200 times 5 is 1,000. How do we get the next number? Multiply by 5. So our next number would be 5,000. What would be next? 25,000. Look how big our numbers are getting. They get big really fast. It went from 8 to 25,000 in 1, 2, 3, 4, 5 terms. Feels kind of like the spread of coronavirus, doesn't it? Exponential growth. Okay, next one. What can we multiply a 2 by to get a negative 4? What do we multiply negative 4 by to get 8? What do we multiply 8 by to get negative 16? Let's see what happens if we divide. So 4 divided by, negative 4 divided by 2. What's negative 4 divided by 2? Negative 2. What's 8 divided by negative 4? Negative 2. What's negative 16 divided by positive 8? Negative 2. What's our common ratio? Negative 2. All right. So what's the next number going to be? If we multiply negative 16 times a negative 2, what's our next number going to be? Negative 16 times negative 2 is going to be 32. What about 32 times negative 2? Awesome. Negative 64. And the pattern would continue from there. Just keep multiplying negative 2. It's not going to get big quite so fast. It's also going to alternate positive, negative, positive, negative, positive, negative, which makes our numbers graph really weird because they would be one positive, one negative. So it's going to bounce back and forth, which is why you just do dots. You don't connect them. Okay, our last one here is a little weird because if we try doing our ratio 27 to 81, we get a fraction. So 27 divided by 81 is 1/3. Do we get the same thing if we do 9 divided by 27? Yeah, we do. We get 1/3 again. What if we do 3 divided by 9? Do we get 1/3 again? We do. What's our common ratio then? Our common ratio is 1/3. And another way of saying that is we could describe it by saying we divide by 3. Multiplying by 1/3 is the same thing as dividing by 3. Does that make sense? So the ratio is the number you multiply, but dividing by 3 would accomplish the same thing. So what's the next number going to be if we divide by 3? Perfect. And then after that, divide 1 by 3, 1/3, right? What happens if you divide 1/3 by 3? You get 1/9, and you just keep getting these smaller and smaller and smaller fractions. They never do. So the graph is going to look like this, and it's going to get closer and closer to 0, but never get there. We call that process an asymptote, in case you've forgotten what that means. It's going to get closer and closer to 0, but never get to 0. Okay. We've got explicit formulas and recursive formulas for geometric sequences as well. We're not going to spend a lot of time on this. Let's go ahead and fill in these blanks. A sub n is the nth term. A sub 1 is the first term. N is the term number. And R is the common ratio. So not going to spend a lot of time on these unless you want to, just so you can learn it. Has some examples there. We are just going to go ahead and practice this by doing just example number 1 for now. So example number 1 says a sub n equals 4 times -2 to the n minus 1 power. They want us to find a sub 12. So that means we're going to plug in a 12 where the n is. So if we plug in a 12 where the n is, 12 minus 1, that means it's going to be to the 11th power. So we're multiplying -2 11 times. If you want, you can put that in a calculator for me and figure out what it will be. And that just means you're multiplying -2 over and over and over. I got -8,192. Since this was a negative R value, that means that it's one of those problems where it's going to alternate positive, negative, positive, negative, positive, negative, positive, negative, etc., right? So I don't want to cause you too much to do here this last week, this first week of January and kind of last week of the quarter. But what would we multiply by on this problem to get the next number? What would R be? What is R? 9 times what is 18? 18 times what is 36? It is 2. If you're having a hard time just doing those in your head, remember you can always go 18 divided by 9 is 2. 36 divided by 18 is 2. Right? So that's how you can find that number if you can't think just in your head what it is. Okay, I'm actually going to have us write the formula. It's just right here at the top. It's this formula right here. We start with the first term and then R to the n minus 1 power. So the first term, what's the first term of our sequence? First term of our sequence is a 9. R is the number that's multiplying each time, and that's a 2. And then we're going to just write n minus 1 power, because right now we don't know what n is. This works for any value of n. So look, the formula we just wrote, all we had to have was the first term and the common ratio. And look at the formula we just worked with in the previous problem. look at how it looks the same. It has an a sub n, it has an n minus 1, it has a number in front, it has a number in parentheses. It's just that the numbers are different. Otherwise, it's kind of the same exact setup, right? Okay, that's all we're going to do with geometric sequences today.